Okay, so just to recap, we've come across a bit of a difference between these two problems. I went over talking about this example and saying that 13 wasn't your x-intercept, or sorry, your y-intercept. And the reason for that is if you look at this graph here, you can see that your y-intercept would be down here at 8. Okay, there's a bit of a problem with that because when we go and look at this problem now, 3 is in fact your y-intercept for this part of the function. The reason why, what we've discovered, is this x here is not a true representation of the independent variable x. Sorry, thanks. This x here is not a true representation of the independent variable x on this axis here. Okay, this x is actually representing the amount of hours above 2 hours. So when we put in 2 here, we're actually putting in a value of 4 for the real value of x, okay, which goes up to 19, which is here. 19, okay? So there is kind of a discrepancy between these two problems, which I can see as being a little bit confusing. Moving forward, and this is the majority of the questions you're going to get are not going to be like this first example. They're going to be more like this example, where you're given two functions, okay? You would graph these functions as is, okay, and then put in the restrictions on their domain. So, counter to what I said in the first example, this 3 is in fact your y-intercept, okay, so it would cross y there, and 2 is your slope, so you're going up. Every one you go over, you go up 2. Okay? So that is your graph. So this is y equals 2x plus 3. Alright? So you can graph one and graph the other, and then you can combine them, which looks like this. Okay? So you can see, if I were to extrapolate this line, it's going to come down and intersect the y-axis at y equals 3. There's my y-intercept. Okay? So, again, counter to what I said initially, when you're given two graphs, or two functions, you're going to graph them as is. The only reason why this example here was not a y-intercept of 13 was because of the way the equation was written. X was not a true representation of the independent variable. It was actually additional hours over the original 2. Okay, so yeah, sorry about that. A little bit confusing. Let's see, the next problem will be a little bit more straightforward. Any questions about this one? It's discontinuous at 2. From 2 equal to 2 and greater, we graph this line, y equals 2x plus 3. And from less than 2, we graph y equals x squared. Okay, so there's my two graphs, and there's my combination of those two graphs. All right. Okay, last example. It gets a little bit fancier with the function. It gives us f at x equals 1 over x, which is the parent. This is our parent function. Okay, we all know what it looks like, but it's only good up to 2, equal and less than 2. So we make this a closed circle. Okay, and then finally after x equals 2, so it's an open circle because of this symbol here, open circle. It's a constant value of 2, so it's just a straight line with a y value of 2. Any questions there? All right. There's one more example. Example 5. So it's 3 parts, all very simple functions. 2 of them are a straight line. The third one is a parabola reflected in the x-axis, okay, with a vertical translation of 4 positive units, right? This can be rewritten like this, okay? They just wrote it the other way to confuse, maybe. Okay, so if we wanted to graph this, then we can graph all 3 very quickly. Let's do it. So the first one is x plus 1, so I have my y-intercept as 1, my slope is 1. Next one, I have a slope of 2, my y-intercept is 1, so it looks like this. And finally, the last one, it's reflected in the x-axis, looks like this, but it's moved up 4. 1, 2, 3, 4. Any questions about these 3 graphs? No? Okay. So the next step is we look at the boundaries and we graph them accordingly. So this graph here is only valid when x is equal to and less than 0. So we're going to graph this up to here. So here's my master graph. I'm going to put it down here. I'm going to graph from here.
So that's an open circle, right?
No, it's closed because of this. Closed. So I have that. Next, from 0 to less than 3, so I'll do 1, 2, 3. I have this graph here. So if I want to start at 3, I can plug in the value of 3 here for x. So I'm going to get 7. So I'll be up at 7. 1, 2, 3, 4, 5, 6, 7. 3 and 7. And it's less than, so that's an open circle. And that's an open circle. Any questions how I drew that part?
Yeah,
Yeah, I can repeat it, sure. So I want to find the boundary points, right? I know it's a straight line, so if I can find the point at 0 and the point at 3, then I can put those 2 circles as open because of this and this, and then just connect them because it's a straight line. So I plug in 0 for x and I get 1. So there's my first point. Next I plug in 3 for x and I get 7. So there's my 7. So 3, 7. So there's my 2 points, open circles because of that, and I connect them. Okay? Any questions? Finally, last one. So greater than and equal to 3. So it's going to be a closed circle, and I'm going to plug in 3. So I get 4 minus 9, which is -5. So I go down here, 1, 2, 3, 4, 5. There's -5. There's 3, and it's a closed circle. So I have to draw the rest of this now because it's greater than and equal to 3. What's happening the rest of this? When I hit -5, I'm on a downward spin. Okay? And these are the same. Any questions? Okay, so in summary, some functions are represented by 2 or more pieces. These functions are called piecewise functions. Each piece of the piecewise function is defined for a specific interval in the domain of the function. Notice how I graphed it. I used those limits to graph. That's what I did, okay? And then I just subbed in values. To graph a piecewise function, graph each piece of the function over the given interval. A piecewise function can be either continuous or not. If all the pieces of the function join together at the endpoints of the given interval, then the function is continuous. Otherwise, it's discontinuous at these values of the domain. Only if they join together.
So, sir, just so you noticed on the quiz that we received the question, the last question, there was a graph where the points were connected.
Okay, hold on, sorry. So let me just. Any other questions about the lesson?